This is part 2 of the vectors video. Make sure, if you haven't already, make sure you watch part 1 first so you know what vectors are before you continue watching part 2. So we're going to start here first with another example, example number 4. So we have vector u in component form -3, 4, vector v component form 1, 6, and we're going to find the magnitude of each scalar multiple, meaning that we have this scalar that's being multiplied by my vector, and we're going to find the magnitude or the length of what this new vector is going to be. So the easiest way to do this is to actually take the scalar multiple out and find the magnitude of just the vector. And when you take the scalar multiple out, since magnitude is just a length, you actually want to take the absolute value of whatever the scalar is. So in this case, we're going to take the absolute value of -7, and then we're going to find the magnitude of just vector u. So the absolute value of -7 is +7, okay? Again, the reason we want that is because we're finding a length, and a length is not going to be negative. And then we're going to find the magnitude of this vector u by using that distance formula I showed you on the last video. So that's going to be the square root of -3 squared plus 4 squared. So that's going to give me 7. Square root of -3 is 9. Plus 4, or -3 squared, excuse me, is 9, and then 4 squared is 16. So that gives me 7, square root of 25, and the square root of 25 is 5, so we get 7 times 5, which is 35. So notice that my answer here is just a number, because again, we're finding the length. So the length of just vector u was 5, and then we multiplied it by that scalar of 7, so the length of 7u, or -7u, would be 35, okay? So let's do part B here. So again, I'm going to take the scalar out, take the absolute value of that, which would be 4, and then we're going to take the magnitude of vector v. Absolute value of 4 is 4, and then taking the magnitude of vector v, we get the square root of 1 squared plus 6 squared. So that gives me 4, and 1 squared is 1, 6 squared is 36. So then I get 4 square root of 37, and the square root of 37 does not simplify, it's not a whole number. I'm going to leave my final answer just like this, okay? No decimals, just 4 square root of 37, okay? And to kind of wrap up the vectors, we're going to look at one last thing, which are the unit vectors. And the unit vectors 1, 0 and 0, 1 are the standard unit vectors that are denoted by I and J. So I is the unit vector 1, 0, which you can see over here in the picture, and J is the unit vector 0, 1, which you can see here in the picture. And these unit vectors are just other ways of representing vectors as opposed to using the component form. So let me show you what that looks like here in a few examples. So let u be the vector with initial point and terminal point. So they're giving us the points, not the component form. We're going to write u as a linear combination of the standard unit vectors I and j. So what I need to do first is actually find the component form of u, and then we're going to write them as something known as the sum of unit vectors. So let's do the component form first. So u equals, so notice I'm going to change to my vector brackets now, terminal minus initial, so -3 minus 5, and -1 minus 2. So u is actually the vector -8, -3. So this is vector u in component form. We've already done that. Now we're going to change this component form to a linear combination of these unit vectors I and j. So what that will look like instead, so remember I goes with 1, 0. So I'm kind of splitting this up just so you guys can see where this is coming from. and j goes with 0, 1. Let me get that 3 that I forgot. So negative 3, 0, 1. And I wrote it like this because the 8 was in that first position and the 3 was in that second position, so I can kind of split it up to look like that. And then I can rewrite this as negative 8. This can be replaced by I minus 3, and this vector can be replaced by j. And so that is taking this component form and writing it as a linear combination of the standard unit vectors. This is going to be on your WebAssign, and WebAssign is kind of picky. You can't just type in I and j. I was trying it earlier. So again, you'll have to go to the Vectors tab on the equation editor, and there is an I and a j in there. You have to use that I and j in order for them to mark it correct. Okay? And if you have any issues with that, feel free to email me. Let's just do one more example like this to wrap up. So again, u is a vector with an initial point given and a terminal point given. We're going to write it as a linear combination of these unit vectors I and j. Let's find the component form first. So terminal minus initial, negative 8 minus negative 2, 6 minus 3 gives me the component form of negative 6, 3. So there's component form of my vector u. Changing that to in terms of I and j, the negative 6 will go with I because it's in the same position, and 3 will go with j. And so vector u can also be written as 6i plus 3j. Negative 6i plus 3j. And that's all for vectors. For this section, we're going to do one more section with vectors, so stay tuned for that.